Here's an example in which we're solving 4 cos 2 theta equals 4 sine squared theta plus 2. So how are we going to handle this? Well, the first thing we've got to notice is that this is a double angle, right? 2 theta. And this is a single angle, just theta. So that specifically means something we have to do. Let's go down and look at your notes. I'm looking at your notes right now that I provided for you. And I'm finding at the bottom of the notes, number 5, double angle and single angle together. So that's what we're talking about. If you have sine 2x, we have cosine. If you have cosine 2x, replace it with one of these two options. Either 2 cosine squared minus 1 or 1 minus 2 sine squared. Those come off your formula sheet. So I'm going to do one of those two. How do you know which one? If the rest of the problem is cosine, do the cosine one. If the rest of the problem is sine, do the sine one. The rest of our problem is sine, so I'm going to use 1 minus 2 sine squared of regular x. See how cosine 2x, double x, is 1 minus 2 sine squared regular x. So that's what we're going to do. Let's go back up to our problem. There it is. So I'm going to replace it right here. So bring down the 4. That isn't going anywhere. And then the cosine 2 theta, that's going to be 1 minus 2 sine squared regular theta. And the right side hasn't changed. So do you see what happened there? The 2 theta became regular theta when I did the formula. Why did I go with the sine? Because the other one's sine. So we've got it all in terms of sine now. Okay, let's distribute. 4 times 1 is 4. 4 times 2 is 8. Sine squared theta is 4 sine squared theta plus 2. Okay, now what in the world should we do? Well, let's go back to our notes. Now we don't have to go to the double angle thing. We just have to look at the beginning of the notes. If you have only one type of trig function, that's what we have. We just have sine everywhere, right? If you have first power only, no, that's not us. If you have second power only, yeah, we have just sine squared, right? Get it alone, then root and plus or minus root over the sides. Ah. All right, let's do it. So I probably should have written out here. So step 1, replace cosine 2 theta with 1 minus 2 sine squared regular theta. We did that. Now step 2, get sine squared theta alone. So I'm going to get it alone. It doesn't really matter which side. I'll just add 8 sine squared theta to both sides, like so. And it cancels. So we get 4 equals, this is 12 sine squared theta plus 2. Let's get rid of that 2. It's gonzo there, and we get 12 sine squared theta. This is 4 minus 2, right, which is just 2. Almost alone. Last step to finish getting sine squared alone is divide by 12, right? Boom, boom. And so then we have sine squared of theta is 2/12. That reduces to be 1/6, right? Just divide top and bottom by 2. Okay, so get the sine squared alone. We did. We got it alone. And then what did the instructions say from there on the notes? It said you're going to do the root on both sides, right? So this is step 3, plus or minus root and root. So you got to put a root here and a plus or minus root on the number side. Are you aware of that? Do you know that it's not just root and root? That's a common, very, very, very common mistake students make. Let me prove it to you. I don't want you just to think it's a math trick and you got to remember. Let me show you. What if you had like x squared equals 9? Now you know that really, what could you plug in here? What number squared is 9? Well, you're like 3, yeah. But also negative 3, right? Negative 3 squared is also 9. So there's actually 2 answers, 3 and negative 3, to this equation. True, you agree, just by observation. 3 squared is 9, and so is negative 3 squared. Both 3 and negative 3 are true answers to this equation. Okay, great, so what? Well, if you root, and that's all you do, and you don't put a plus or minus, see how you'll only get the 3, you won't get the other answer? So that's my point. When you put a root on both sides, you've got to put plus or minus on the number side to get all the answers. Otherwise, you miss half the answers. So you really have to remember this. I had so many students that just kept forgetting this forever, so I made up a really dorky saying. It's my dorkiest, probably. Hesitate to say it, but it helps people. They've done better since I said it, so here you go. When you put a roof on the house, root is like a roof. You've got to go up and down the ladder. Up and down, that's my plus and minus. It's pretty lame, but it's best I can do. Plus and minus. You got to go up and down the ladder, right? If you're going to put a new roof on your house, what if your house the roof had holes in it? You had to put a new roof. To do that, you can't just jump on the roof, probably. You need a ladder. You're going to have to go up and down the ladder. That's my plus and minus. So if you put a root on both sides of anything in math, you've got to go up and down the ladder. You've got to put plus and minus on the number side. All right, that's the best I can do. You got to remember it from there. So, okay, get back to the problem. Otherwise, you'll miss half the answers. So, back to the question. So, I did root and plus or minus root. So, this cancels, right? That's why I did it. So, basically, let's write two things. So, this is sine of theta, right? Because this, well, here, let me go a little slower. So, sine of theta is plus or minus square root of 1/6, right? These cancel, the root and the 2 powers. So, it's just, we got the sine alone. So now, what step are we on? We have step, get sine squared alone. I should have written step 3 here. Root, oh, I just erased it, didn't I? M plus or minus root. Okay, and now, step 4, write 2 equations. Just separate them. So write sine of theta is plus square root of 1/6, or sine of theta is minus the square root of 1/6, right? Just two separate, the plus and the minus. Just break it into 2 separate equations. Now we've got to solve both of those equations. How do we do it? Well, this is not on the unit circle, right? So square root of 1/6 is not on the unit circle. You could go look at the unit circle. It just has other numbers, not square root of 1/6. So use the calculator. We've got to use the calculator, and we've got to use inverse sine. So how are we going to do it with inverse sine? How's that going to happen? So to get inverse sine, I've got to come down here. Let me, Alexa, play a different song. Sorry, it's playing in the background, and I didn't want any words. All right, on we go with this problem. Where am I at? Oh, I'm getting totally lost. I get distracted by what I'm doing with my thing. All right, so what are you supposed to do? Wait, we're on the wrong one. When we must use our calculator, how do we do it? You get the sine, cosine, tangent alone, take the inverse, both sides, but before hitting the inverse, you must make it positive, even if it was negative. Then realize your answer is first quadrant because you made it positive. Then go to the 2 quadrants, and there you go. So we've done this before. I'll walk you through it again. So, so basically, I take this first one, and I go, okay, I'm gonna do sine inverse of this side and sine inverse of that side. And so this is sine inverse of the sine, and this is sine inverse of the positive root 1/6. So that one already is positive, so I don't have to mess with it. Cancel these out, and so we get theta alone, right? That's why we do sine inverse, because sine inverse is the opposite of sine, cancels it out. Hit the buttons on your calculator. Make sure you're in radian mode right here, and hit the sine inverse on your kid. Check your mode. Make sure you're in radian mode. Sine inverse of the square root of 1/6, and I'm getting 0.42053. That's enough digits. All right. So now what do we? That's my angle, but that's not the only answer. That's not the only answer. We've got to get two answers. How do we know where they are and what they are? Well, you have to realize which two quadrants. Remember the all students take calculus thing, right? All are positive here. Students take calculus. So in which, what was my original question? Where is sine, I'm trying to solve, where is sine of theta positive? Square root of 1/6. So where's sine positive? Which two quadrants? Here and here. Sine positive, right? All are positive in the first quadrant, including sine, and sine is positive in the second. So first and second quadrant. So this is the quadrant 1 answer already. That's the quadrant 1 answer. What's the quadrant 2 answer? Well, you can go down to this formula I gave you. Right here, I gave you the instructions for how to, first quadrant, no change needed. Second quadrant, pi minus the inverse calculated value. So it's pi minus the inverse calculated value. So I'm going to go up here and go theta. The other one, well, I don't say theta, it's just going to be pi minus that 0.42053 thing, which equals, I don't know. I'm going to use the pi button on my calculator. And I'm getting 2.721058. There we go. Okay, use a bunch of digits just to be safe. So here's one answer. Here's a second. And why did we do that, by the way? Let me give you the reason. Because that first answer is here in the first quadrant. That's the 0.420534. And then the second quadrant, it's the same thing. It's just 0.420534 in the second quadrant, but how you say second quadrant answers is from 0 all the way to there, which means you got to go all the way to what? Pi, and then back up the 0.420. That's why it's pi minus back up. All right, so there's the first. You don't have to memorize that. I gave you the formula on the sheet. So there's that. Now, let's come over here, and now we've got to do the other side. Right? Because we've only done half the battle here. We got to come over here and we got to solve this side. So to do that, you're going to take sine theta equals positive square root of 1/6. You've got to change to positive. See how I changed the negative? I changed it to positive. Why? Because that puts it in the first quadrant. All those instructions are there in the notes. Hopefully you're familiar with this by now. I'm going to do sine inverse and sine inverse of both sides. Let me move that over just a little bit. Of both sides here. And of the sine of theta and of the positive square root of 1/6. These cancel, get theta alone. I don't need to go to my calculator. I just did that right here. Right? Sine inverse of positive root 1/6. It's going to be that same number, 0.420534. Now, that's my first quadrant answer. But I don't want a first quadrant answer on this side. Let me show you what I mean. Let me draw the coordinate thing on this side. What are we solving? We're solving for sine negative. Other side was sine positive root 1/6. This side is solving sine negative root 1/6. So let's do the all students take calculus. Where is, we're trying to solve sine, the original question is that we're trying to solve now is negative. So the original, before I changed it to positive just to help me get the calculator value because that gets me a first quadrant answer. But now, to finish up this problem, I need to go back to the original question, which was negative. Where is sine negative? Sine is negative here and here. Sine negative here and sine negative here, right? Because it's positive. Everything's positive here and sine's positive there, so it's not the first and second quadrant. It's the third and fourth. So I got to get a third and fourth quadrant answer. How do you get those? Well, you can look at the formula. For the third quadrant answer, you've got to take pi plus your number, so pi plus that 0.420534. And for the fourth quadrant answer, you've got to take 2 pi minus that number, 0.420 534. Why? Because the original one, like I said, is first quadrant right here, 0.420534. So if you want that same thing in the third quadrant, see what you got to do? You got to go to pi and then go add to it the 0.420534. That's why it's pi plus to get the third. To get that same thing here in the fourth quadrant, which is again the same opening, 0.420534. That's why we found it. It's the same thing in every quadrant, but how do you express a fourth quadrant answer? You've got to go from 0 all the way to there, which means go all the way to 2 pi and back up the 0.420, right? All the way to 2 pi, back up, minus. All right, enough said. This problem's going forever. Let's get some answers to this thing. So pi plus 0.420534 equals, Alexa, play a different song. There we go again with that. 562, so 2126, and then this one, we go 2 times second pi minus 0.420534. This is like a 3-song problem, I think. 5.86265. That was crazy long. So what are our 4 answers? We had 2 answers here. So this guy and this guy. So answers, there's 4 answers. What are they? The 0.420534, right, that we got originally, and the 2.721058. So that's the 2 we got here. And then that one and that one. 4 answers all together. There we go. Difficult question, probably the hardest section in